long before forests covered continents, before birds crossed the sky, before the first dinosaur took a step across ancient ground, belonged to a different world. It was a world shaped by oceans so vast that they seemed endless, stretching beyond every horizon beneath skies that no human eye would ever witness. The familiar planet we know today did not yet exist. There were no cities glowing at night, no ships cutting across distant waters, no lighthouses, satellites, constellations of electric lights scattered across the surface. When darkness arrived, it arrived completely. Imagine standing beside one of those ancient seas hundreds of millions of years ago. The shoreline would feel unfamiliar. The air itself might seem strange. Waves would still rise and fall, driven by the same forces that move oceans today. Everything beyond the surface concealed a mystery unlike anything in the modern world. Beneath those waters lived countless organisms. Some drifted with currents. Others crawled across the seafloor. Predators searched for food while prey searched for safety. Life was already experimenting with extraordinary forms and behaviors, yet one thing was largely absent. Light, not sunlight, still illuminated the upper layers of the ocean during the day. Not moonlight, which occasionally reached calm waters during clear nights. The missing light was something else entirely. The ocean had not yet become the glowing realm many people imagine today. It lacked the countless flashes, pulses, and shimmering displays produced by modern bioluminescent creatures. Instead, darkness ruled. As sunlight faded beneath the horizon, the deeper waters became almost impossible to see through. Visibility was often measured not in great distances but in mere inches. Beyond that, everything dissolved into blackness. Shapes vanished. Boundaries disappeared. The ocean became a world where sight offered little advantage. And yet life continued. Predators still hunted. Prey still escaped. Mates still found one another. Entire ecosystems functioned without relying on the visual signals that dominate much of the natural world today. Creatures sensed vibrations moving through water. They detected faint chemical traces left behind by other organisms. Some responded to subtle changes in pressure. Others followed invisible currents carrying information through the darkness. To modern observers, such a world seems almost impossible to imagine. Vision feels so important that it is easy to assume life would struggle without it. Evolution rarely depends upon a single solution. When one pathway becomes difficult, another often emerges. For millions upon millions of years, these strategies were enough, which makes the next chapter of the story so strange. At some point, certain organisms began producing light themselves. Not sunlight borrowed from above, not reflections from the surface, their own light. The idea raises a question that remains surprisingly difficult to answer. Producing light requires energy. Energy is valuable. Every living thing competes constantly for limited resources. Evolution tends to eliminate waste, not encourage it. So why would any organism invest precious energy into creating light? At first glance, the decision seems almost irrational. Life had already discovered countless ways to survive in darkness. It could hunt without seeing, hide without glowing, communicate through chemistry rather than illumination. Darkness was not merely an obstacle. In many ways, it was protection. Somewhere within those ancient oceans, something changed. What appeared to be a perfectly successful world began moving toward one of the strangest innovations in the history of life. The darkness was not simply a backdrop to evolution. It was shaping evolution itself. And hidden within that immense black ocean, an impossible glow was waiting to be born. The ancient ocean was not empty darkness. It was a living darkness. Beneath the surface, countless organisms moved through black waters with a confidence that seems almost impossible from a modern perspective. They possessed no flashlights, no glowing signals, and in many cases only the most limited forms of vision. Yet they survived. They hunted, escaped danger, found mates, and passed their genes into the future for millions of years. The deeper one looks into this forgotten world, the stranger it becomes. Today, humans often think of sight as the primary way to understand the environment. Eyes dominate our experience. We trust what we can see. Ancient marine life evolved under very different conditions. In waters where darkness swallowed nearly everything, vision was often unreliable. Other senses became far more important. Some creatures learned to detect the faintest disturbances moving through the water. A nearby predator could create tiny vibrations that traveled outward like invisible ripples. To organisms sensitive enough to detect them, these disturbances revealed information long before physical contact occurred. Others relied on chemistry. Every living thing leaves traces of itself behind. Ancient organisms released molecules into the surrounding water as they moved, fed, and reproduced. Certain species became remarkably skilled at reading these invisible trails. What appeared to be empty ocean was actually filled with signals. To the right organism, a single chemical trace could reveal food, danger, or opportunity. There were also creatures that seemed almost supernatural in their abilities. Some could sense changes in water pressure so subtle they bordered on the unbelievable. Others responded instantly to environmental shifts far beyond the limits of what human senses can detect. They occupied a world rich with information, even though almost none of that information depended on light. In many ways, darkness was not an obstacle, it was an advantage. A hidden creature is difficult to find. A predator cannot easily chase what it cannot see. A small organism drifting through black water could remain nearly invisible simply by existing within the darkness around it. No camouflage was required. The environment provided concealment automatically. This protection carried enormous value. Producing specialized defenses requires energy. Growing armor requires energy. Escaping predators requires energy. Darkness offered a solution that cost nothing. It surrounded every organism equally, creating one of nature's most effective shields, which makes the next development increasingly difficult to explain. If darkness already provided safety, why would any organism begin creating light? The question becomes more puzzling the longer it is considered. Imagine revealing your location in a world where remaining unseen offers protection. Imagine spending precious energy to generate a signal visible to others. From an evolutionary perspective, the idea appears risky, perhaps even dangerous. Yet evolution rarely produces costly traits without a compelling reason. Something must have changed. Somewhere within these ancient ecosystems, pressures were beginning to build. Predators improved, competition intensified, survival became more challenging. Organisms that once relied upon established strategies may have encountered new problems those strategies could no longer solve. The evidence suggests that ancient oceans were not static environments. They were dynamic systems filled with constant competition. Every successful adaptation created opportunities for rivals to develop countermeasures. Every advantage encouraged new forms of response. Slowly, almost invisibly, an evolutionary contest may have been unfolding beneath the surface. At first, the changes would have seemed insignificant. One species develops a slight advantage, another adapts in return, a third discovers a different solution altogether. Across millions of years, these small adjustments accumulate into transformations capable of reshaping entire ecosystems. This possibility introduces a deeper mystery. Perhaps bioluminescence did not appear because organisms wanted light. Perhaps it appeared because they needed something that darkness alone could no provide. The black void had sheltered life for ages. It had hidden predators, protected prey, and shaped countless evolutionary pathways. Somewhere in Earth's distant past, the balance began to shift, and as those pressures grew stronger, the stage was being prepared for one of the most extraordinary developments in the history of life. By now, the mystery seems simple enough to state, yet remarkably difficult to answer. Why did life begin producing light? Modern science can explain much of how bioluminescence works. Researchers have identified molecules, chemical reactions, and biological systems capable of generating flashes, pulses, and glows. In laboratories, these processes can be observed, measured, and studied in extraordinary detail. The mechanics are increasingly understood. The deeper question is far less cooperative. Knowing how something works is not the same as knowing why it appeared in the first place. When scientists look back across Earth's distant history, they encounter a puzzle hidden beneath millions of years of evolution. The organisms that first produced light left behind few clues. No fossils preserve flashes, no ancient record explains their purpose. All that remains are fragments of evidence and a collection of intriguing possibilities. One theory suggests that the earliest glow may have emerged entirely by accident. Life depends upon countless chemical reactions occurring inside cells. These reactions release energy, transform materials, and keep organisms alive. Occasionally, chemistry produces unexpected outcomes. Under certain conditions, energy can escape in the form of visible light. If this happened in ancient organisms, the first glow may not have been a deliberate adaptation at all. It may have been nothing more than an unintended side effect of ordinary biological activity. Imagine that possibility for a moment. One of the most beautiful phenomena in nature beginning not as a strategy, not as a signal, and not as a weapon, but as an accident. Other researchers have proposed variations on the same theme. Perhaps ancient molecules occasionally released faint flashes during metabolic processes. Perhaps primitive organisms generated tiny bursts of light without gaining any immediate benefit from them. The glow may have existed long before evolution discovered a use for it. But there is another idea that many scientists find especially fascinating. To understand it, it helps to remember that oxygen has not always been a simple advantage for life. Today, oxygen supports countless organisms, including humans. Yet oxygen can also be dangerous. Inside living cells, certain oxygen-related reactions produce unstable compounds capable of causing damage. Organisms must constantly manage these threats to survive. Some researchers believe the earliest biological light may have emerged during this struggle. According to this hypothesis, ancient organisms developed chemical processes that neutralized harmful reactions occurring within their cells. As energy was released during those protective processes, a small amount escaped as light. If this theory is correct, the first glow in Earth's history was never intended for communication. It was never intended to attract mates. It was never intended to confuse predators or illuminate darkness. It may have been biological waste, faint byproduct produced while organisms protected themselves from chemical harm. The idea feels almost unbelievable. Glowing displays that now illuminate oceans around the world seem purposeful, elegant, even magical. Yet their distant origins may have been surprisingly mundane. Nature often works this way. Evolution rarely plans ahead. It modifies what already exists, turning accidents into opportunities and side effects into advantages. That possibility changes the entire story. Perhaps the first organisms capable of producing light gained no direct benefit from being visible. Perhaps they were simply solving a completely different problem. The glow itself may have been incidental. Then something remarkable happened. Evolution noticed. Over immense spans of time, any feature that provides even the slightest advantage can be refined. A weak flash becomes useful. A useful flash becomes valuable. A valuable flash spreads through populations and transforms ecosystems. Began as chemistry could become communication. What began as waste could become survival. And what began as an accident could eventually reshape life in ways those ancient organisms could never have imagined. The mystery remains unsolved. No scientist can travel back through time to witness the first glow. The exact origin may forever remain hidden within Earth's distant past. Yet one possibility stands above the others in its sheer strangeness. The first creature to produce light may never have meant to glow at all. And if that is true, then an even greater question now waits beneath the surface of history. How did a biological accident become one of evolution's most powerful inventions? To understand how living light may have first appeared, it is necessary to leave behind the vastness of ancient oceans and travel somewhere much smaller, far smaller. The story now moves into a hidden realm beyond the reach of sight, deep inside microscopic organisms drifting through prehistoric seas. Here, there are no predators lurking in the darkness and no dramatic flashes illuminating the water. There are only cells, molecules, and the quiet chemistry of survival. At first glance, it seems like an unlikely place for one of nature's greatest mysteries to begin. Yet this invisible world may hold the answer. Hundreds of millions of years ago, Earth's oceans were changing. Oxygen, scarce in many environments, was becoming increasingly available. For living organisms, this created extraordinary opportunities. Oxygen allowed more efficient ways of generating energy, opening pathways that could support greater complexity and growth. Every opportunity carries consequences. The same oxygen that helped sustain life could also create problems. Certain chemical reactions produced unstable compounds capable of damaging delicate cellular machinery. Organisms were forced to navigate a world where a valuable resource could also become a threat. Inside countless microscopic cells, chemical reactions unfolded continuously. Molecules collided, separated, transformed, and recombined. Energy flowed through these processes in endless cycles. Most of the time, that energy served practical purposes. It powered movement, growth, and survival. Occasionally, however, something unusual happened. A small amount of energy escaped, not as heat, not as motion, as light. Today, scientists understand that specific compounds can produce this effect. Among the most famous are substances known as luciferins and enzymes called luciferases. Their names sound almost mythical, as though they belong in legends rather than biology. Yet these molecules are very real. Imagine them as characters in an ancient drama. One carries stored energy. The other helps unlock it. When they meet under the right conditions, a reaction occurs. Energy is released, and part of that release appears as visible light. The result may be a faint glow, a flash, a shimmer lasting only moments. To modern eyes, such an event feels extraordinary. To ancient cells, it may have been routine. This possibility changes the entire perspective of the story. What if the earliest flashes were not rare events at all? What if they occurred countless times throughout ancient oceans, unnoticed and insignificant? Millions of microscopic organisms performing ordinary chemistry, occasionally producing tiny sparks of light as a side effect. The ocean would not suddenly burst into illumination. Instead, faint flashes might appear here and there, scattered across vast stretches of water, each one carrying no purpose beyond the chemistry that created it. Then evolution did something remarkable. It paid attention. One of the most surprising discoveries in modern biology is that bioluminescence did not evolve only once. Scientists have found evidence suggesting that living light emerged independently many times throughout Earth's history. Again and again, unrelated organisms discovered ways to glow. Different lineages, different environments, different evolutionary paths. Yet somehow they arrived at similar outcomes. This repetition is difficult to ignore. Evolution is often compared to an inventor working without a blueprint. It experiments endlessly, producing countless failures alongside occasional successes. When the same solution appears repeatedly, it usually means that solution offers something valuable. Light appears to be one of those solutions. The earliest flashes may have been accidental. The chemistry that produced them may have evolved for entirely different reasons. Yet once light existed, even in the smallest amounts, natural selection gained something new to work with. A faint glow could become useful, a useful glow could become advantageous, and an advantageous glow could spread. The realization is both simple and profound. Biological light may not have been a singular miracle hidden within Earth's past. It may have been a recurring answer to recurring challenges, discovered over and over because the benefits eventually outweighed the costs. Somewhere within those ancient oceans, chemistry had accidentally opened a door. What lay beyond that door would change the history of life forever. Somewhere in the immense darkness of Earth's ancient oceans, a small event may have changed everything. It was not dramatic. Explosion illuminated the sea. No sudden transformation swept across the planet. If anyone had been there to witness it, probably would have missed it entirely. A faint glow appeared. Then it vanished. Yet hidden within that insignificant moment may have been the beginning of one of evolution's greatest success stories. The earliest organisms capable of producing light were unlikely to resemble the spectacular glowing creatures that inhabit modern oceans. Their flashes may have been weak, inconsistent, and barely noticeable. They were not masterpieces of biological engineering. They were experiments, and like many evolutionary experiments, they may have begun by accident. The difference now was that the accident existed. Once a trait appears, natural selection gains the opportunity to shape it. Imagine a tiny organism drifting through dark water. Somewhere within its cells, chemical reactions occasionally produce a faint flash. Most of the time, the glow changes nothing, appears briefly and disappears into the darkness. Then one day, by chance, the flash matters. Perhaps a predator approaching from nearby is startled for a fraction of a second. The hesitation is tiny, almost meaningless, yet it gives the glowing organism enough time to escape. Or perhaps the opposite occurs. Maybe a small prey organism reacts to the light, making itself easier to detect. A hunter that glows gains a slightly better chance of finding food. Another possibility is even simpler. In the vast darkness of ancient oceans, locating others of the same species may have been difficult. Faint glow could make an individual easier to find. If that increased the likelihood of reproduction, the advantage would be powerful indeed. No one knows which scenario came first. Perhaps several occurred simultaneously. Perhaps entirely different benefits emerged in different environments. The exact details remain hidden within deep time. What matters is not the specific advantage. What matters is that an advantage existed at all. Evolution does not require perfection. It does not demand dramatic improvements or revolutionary breakthroughs. A tiny edge is enough. If one organism survives slightly more often than another, its descendants become a little more common. If those descendants inherit the same trait, the process repeats. Generation after generation, the advantage accumulates. The changes are almost impossible to notice in a single lifetime. Evolution is patient. While mountains rise and erode, while continents drift across the planet, natural selection continues its quiet work. Small differences compound. Minor benefits grow larger. Features that once seemed insignificant become increasingly refined. First glow may have been little more than a biological curiosity, yet curiosity can become utility. Utility can become necessity, and necessity can reshape entire ecosystems. This is one of the most remarkable aspects of evolutionary history. Many of nature's greatest innovations began in humble ways. Wings were not always capable of flight. Eyes were not always capable of detailed vision. Complex systems often emerge from simple beginnings. Bioluminescence appears to follow the same pattern. A weak flash becomes slightly brighter. Brighter flash becomes more reliable. A reliable flash becomes specialized. Over millions of years, started as a faint chemical side effect evolves into a sophisticated biological tool. Process unfolds so gradually that no single generation notices the transformation. Yet the result is extraordinary. An adaptation that once offered a small advantage becomes capable of influencing survival, reproduction, communication, behavior across entire species, and once one organism gains success through light, others face a choice: adapt, compete, or fall behind. Slowly, almost invisibly, the evolutionary landscape begins to change. What was once rare becomes more common. What was once accidental becomes increasingly purposeful. The darkness remains, but it is no longer the same darkness. Tiny flashes are beginning to appear within it. More importantly, those flashes are starting to matter. And as living light spreads through ancient oceans, it creates new opportunities, new challenges, and new conflicts that will shape the future of life in ways no organism could possibly foresee. The first glow did not transform the ocean overnight. Countless generations, bioluminescence remained a small and uncertain experiment. Faint flashes appeared in scattered organisms, offering subtle advantages that only slowly revealed their value. The darkness still dominated. The ancient seas remained vast, mysterious, and overwhelmingly black, yet something fundamental had changed. For the first time in Earth's history, no longer belonged exclusively to the sun, the moon, or the stars. Life itself had become capable of creating it. That single development opened possibilities evolution had never possessed before. Once a trait proves useful, natural selection rarely leaves it untouched. It begins modifying, refining, and experimenting. Every variation becomes an opportunity. Every improvement creates new possibilities. Across millions of years, what begins as one solution can branch into hundreds. Bioluminescence appears to have followed exactly this path. Some organisms discovered that light could help them avoid becoming a meal. A sudden flash might startle an approaching predator. In the confusion, precious moments could be gained. Those moments might mean survival. Other organisms found opportunities in the opposite direction. Instead of escaping predators, they became more effective hunters. Faint glow could attract curious prey. A brief flash might expose movement hidden within darkness. Organisms capable of controlling light gained new ways to interact with their environment. Elsewhere, entirely different strategies emerged. Certain species may have used illumination to disguise themselves. Others likely employed glowing patterns that made their outlines difficult to recognize. What seems obvious today, that light makes something easier to see, was not always true. Under the right circumstances, light could conceal as effectively as it revealed. Evolution continued experimenting. No single design dominated. No universal blueprint existed. Different environments rewarded different approaches. The ocean became a laboratory operating on a planetary scale, testing countless variations of the same remarkable ability. As generations passed, the consequences grew larger. The darkness was no longer an empty backdrop surrounding life. It had become part of an interaction. Every new flash carried information. Every glow created possibilities. Every illumination altered the relationship between organisms and their surroundings. Slowly, ancient ecosystems began changing. Creatures that relied solely on traditional survival strategies now encountered competitors equipped with something entirely new. Predators faced unfamiliar defenses. Prey confronted unfamiliar threats. Evolutionary pressures shifted across the food web. What had started as a microscopic chemical reaction was becoming an ecological force. This transformation may have unfolded so gradually that no single moment marked the beginning of the revolution. Yet from a broader perspective, the change was profound. Entire ecosystems were learning how to incorporate biological light into their daily existence. The evidence for this success remains visible even now. Modern oceans are filled with descendants of those ancient experiments. In some regions of the deep sea, biological light is so common that many visible interactions involve bioluminescence in one form or another. Organisms flash, shimmer, pulse, and glow throughout environments where sunlight never reaches. Researchers exploring these depths often encounter scenes that seem almost impossible. Sudden bursts of blue light appear in darkness. Waves of illumination ripple through invisible communities. Organisms communicate, hunt, and defend themselves using strategies developed over immense spans of evolutionary time. The astonishing truth is that these modern displays trace their origins back to the tiny flashes that first appeared in ancient oceans hundreds of millions of years ago. The strategy worked. It worked so well that evolution rediscovered it repeatedly and refined it endlessly. What began as chemistry became adaptation. What became adaptation transformed into innovation, and innovation reshaped entire ecosystems. The story was still only beginning. The earliest uses of bioluminescence focused primarily on survival, escaping danger, finding food, improving the odds of reproduction. Important advantages, certainly, but evolution rarely stops at the first successful solution. Once organisms learned to produce light, another possibility emerged. Light could do more than help an organism survive. It could send information. Flash could mean something. A pattern could carry meaning. The glow was beginning to evolve beyond a simple tool. Somewhere within the darkness of ancient oceans, living light was preparing to become something even more extraordinary. It was preparing to become a language. Millions of years, light existed primarily as a tool of survival. A flash could startle a predator, a glow could attract prey, an illuminated outline might provide an advantage that helped one organism outcompete another. These uses alone were enough to ensure the spread of bioluminescence throughout ancient oceans. But evolution rarely stops at a successful invention. Once a capability exists, it often acquires new purposes that no organism could have anticipated when the process began. Somewhere within the darkness of prehistoric seas, biological light crossed an invisible threshold. It began carrying information. At first, change may have been subtle. Ancient oceans remained vast and overwhelmingly dark. Visibility was still limited. Most organisms continued relying on the senses that had served them for ages, yet one feature made light unique. Even the smallest flash was difficult to ignore. In a brightly lit environment, a faint signal can disappear into the background. In darkness, however, the opposite is true. A brief pulse becomes noticeable. A tiny glow stands out. The surrounding blackness amplifies its significance. This created an opportunity. Imagine two organisms drifting through dark water. One produces a faint flash. The other responds by changing its behavior. Perhaps it moves away. Perhaps it approaches. Perhaps it pauses momentarily. The exact reaction matters less than the fact that a reaction occurred at all. Once one organism can influence another through light, primitive form of communication has begun. No conscious decision is required, no planning is involved. The organisms themselves may not understand what is happening. Natural selection does the work on their behalf. If certain glowing patterns consistently trigger useful responses, the individuals producing those patterns gain an advantage. Generation after generation, those advantages accumulate. A random flash becomes more predictable. A predictable flash becomes more reliable. A reliable flash becomes a signal. Slowly, the ocean acquires a new layer of interaction. Perhaps a particular pulse discourages competitors from approaching valuable territory. Individuals that produce the signal avoid unnecessary conflict and conserve energy. Over time, the pattern spreads. Elsewhere, another species may discover that rhythmic flashes increase the likelihood of encountering potential mates. Organisms responding to those signals reproduce more successfully. Their descendants inherit both the ability to produce the glow and the tendency to respond to it. In another corner of the ocean, a sudden burst of light may consistently confuse predators long enough for prey to escape. The behavior becomes increasingly refined with each passing generation. None of these developments require intelligence in the modern sense. That is what makes them so remarkable. Humans often associate communication with language, thought, and awareness. We imagine messages being intentionally created and intentionally understood. Yet communication can exist long before such complexity emerges. A signal only needs to influence behavior. By that definition, some of the earliest communication systems on Earth may have appeared hundreds of millions of years before complex brains evolved. The realization is surprisingly profound. people imagine the first messages ever exchanged in Earth's history, they often picture sounds, movements, or perhaps chemical signals. Few consider the possibility that ancient organisms may have been communicating through flashes of light long before intelligence took recognizable forms, yet the evidence suggests this possibility cannot be dismissed. In the darkness of ancient oceans, information may have traveled through illumination, tiny pulses, brief flashes, moments of brightness appearing and disappearing against an endless black background. What began as chemistry became survival. Became communication. And once communication enters the story, evolution gains an entirely new set of opportunities. Signals can become more detailed, patterns can become more complex, responses can become more specialized. The process unfolds slowly, its implications are enormous. The ocean is no longer populated merely by organisms that glow. It is beginning to fill with organisms that use light to influence one another. The first conversations may have been simple. They would not remain simple for long. As millions of years passed, evolution continued experimenting, transforming faint flashes into increasingly sophisticated displays that would eventually reshape relationships throughout the ancient seas. Survival is important. Every predator avoided, every meal captured, and every danger escaped increases the chance that an organism will live another. Yet from evolution's perspective, survival alone is never the final goal. A creature can survive for years, even decades, and still leave no lasting mark on the future if it fails to reproduce. Life is measured not only by persistence but by continuation, and somewhere within the darkness of ancient oceans, biological light may have become one of the earliest tools ever used in the search for connection. The challenge was considerable. Finding another member of the same species is easy in a crowded environment filled with visibility. It becomes far more difficult in vast underwater spaces where darkness conceals almost everything beyond a short distance. Ancient oceans stretched endlessly in every direction. Organisms drifted, swam, and wandered through enormous volumes of water. Potential mates could be surprisingly difficult to locate. In such a world, even a small advantage could matter. Imagine an organism capable of producing a faint glow. The light is not bright enough to illuminate the surrounding environment, but it is visible. Another individual of the same species notices it from nearby. A meeting occurs that otherwise might never have happened. The result is simple: more offspring. And in evolution, few rewards are more powerful than that. Generation after generation, natural selection would favor traits that improved these encounters. Organisms producing more recognizable signals would gain an advantage. Individuals better at responding to those signals would gain an advantage as well. The process would not happen all at once. Every major evolutionary transformation, it would unfold gradually. A flash becomes slightly brighter, a pulse becomes more consistent, a random signal develops a recognizable rhythm. Across immense spans of time, these subtle refinements accumulate. Soon, the ocean is no longer filled merely with glowing organisms. It contains organisms displaying information about themselves through light. Some signals may indicate species identity. Others may reveal health, strength, or maturity. Certain patterns could function almost like introductions, allowing individuals to recognize one another within darkness. The exact details remain hidden within Earth's distant past, but the broader pattern appears familiar. Even today, countless species use displays to attract mates. Birds sing, insects produce sounds, mammals perform elaborate behaviors. Bright feathers, impressive antlers, and complex dances all serve similar purposes. The underlying principle remains the same. Individuals advertise qualities that increase their chances of reproduction. Makes ancient bioluminescence so fascinating is the possibility that this process began extraordinarily early, long before birds filled forests with songs, long before mammals appeared, long before many of the courtship behaviors familiar today even existed. Certain organisms may have been using light to stand out from the crowd. This possibility introduces a surprising idea. Beauty itself may have roots in darkness, not beauty as humans define it, but the evolutionary forces that shape attraction. Characteristics considered appealing often emerge because they signal desirable qualities. The process is ancient, far older than humanity, perhaps far older than most people realize. A brighter flash may have suggested better health. A more precise rhythm may have indicated greater fitness. A distinctive pattern may have helped individuals recognize suitable partners more efficiently. Over millions of years, preferences and displays could evolve together, influencing one another in an endless cycle of refinement. The story suddenly feels both alien and familiar. The organisms involved were nothing like humans. Their world was unimaginably different. Yet the search for connection, the drive to find and attract another individual, links them to nearly every living creature that followed. Across the darkness of ancient seas, tiny flashes appeared. Some were signals, some were responses, some may have marked the beginning of relationships that allowed entire lineages to continue. Perhaps the first great courtship displays on Earth were not songs carried through the air. Perhaps they were pulses of light moving silently through black water. Yet not every signal carried friendly intentions. As bioluminescence became more effective and more widespread, other organisms began discovering that light could serve purposes far darker than attraction or communication. For a time, light served relatively straightforward purposes. It helped organisms survive. It helped them find one another. It increased opportunities for reproduction and communication. The ancient oceans were gradually becoming filled with glowing signals, carrying useful information through the darkness. Evolution possesses a habit that appears again and again throughout the history of life. Whenever a system becomes useful, someone eventually learns how to exploit it. Communication creates understanding. Understanding creates expectation. And expectation creates an opportunity for deception. Somewhere within the ancient seas, organisms began discovering that light could do more than reveal the truth. It could manipulate perception. The shift may have started innocently enough. A particular flash triggers a predictable reaction in another organism. A pulse causes movement. A glow attracts attention. Over countless generations, these relationships become increasingly reliable. Once that reliability exists, natural selection gains access to a powerful new possibility. False signals. Imagine a small predator drifting through dark water. Nearby organisms have evolved to investigate certain flashes because those flashes often indicate food or potential mates. Predator does not need to overpower every prey item through speed or strength. Instead, it produces a signal that attracts curiosity. Prey approaches willingly. The deception succeeds. A strategy is born. Elsewhere in the ocean, different forms of trickery emerge. An organism confronted by a predator releases a sudden burst of light. The flash creates confusion, disrupting the attack just long enough for escape. Predator does not necessarily understand what happened. It simply loses sight of its target for a critical moment. Again, the strategy succeeds. Again, natural selection takes notice. In another environment, an even stranger possibility develops. Certain organisms begin imitating signals that do not belong to them. A glow normally associated with one species appears in another. Organisms responding to the familiar signal are misled. The ocean becomes increasingly difficult to interpret. Not every flash means what it appears to mean. Not every signal can be trusted. The remarkable truth is that none of this requires intelligence in the human sense. No creature sits in darkness planning elaborate schemes. Deception evolves gradually, just as every other adaptation evolves. If a misleading signal improves survival, individuals using that signal become more common. The process is automatic, yet the results can seem astonishingly sophisticated. Evolution had discovered something profound. Controlling perception could be as valuable as physical power. Creature no longer needed to outrun every predator if it could distract one. It did not always need stronger defenses if it could create confusion. Sometimes the most effective survival strategy involved altering what another organism believed was happening. The implications were enormous. For millions of years, evolutionary competition focused primarily on physical traits. Speed, size, strength, armor, and sensory abilities determined success. Now an entirely new battlefield was emerging. Information itself was becoming a resource. The ability to send, interpret, conceal, or manipulate signals created opportunities unlike anything that had existed before. As more organisms adopted bioluminescence, these opportunities multiplied. One species developed a new signaling strategy. Another evolved a response. Third found a way to exploit both. Every innovation generated fresh challenges. Every successful adaptation encouraged counter-adaptations. The ocean entered a period of increasing complexity where light served dozens of different functions simultaneously. Communication, attraction, defense, predation, deception. The glow that once appeared as an accidental byproduct of chemistry had become something far larger. It was no longer a single adaptation serving a single purpose. It had evolved into an entire platform upon which countless survival strategies could. The possibilities seemed almost endless, and evolution continued exploring them. Across vast stretches of dark ocean, flashes appeared with growing frequency. Some revealed intentions, others concealed them, some attracted, others repelled. Every signal carried potential consequences. The darkness itself was changing, not because it was becoming brighter, because it was becoming more complicated. Ancient seas were filling with organisms that understood, in their own evolutionary way, power of light. And as more species joined this contest, the oceans began transforming into something new, a battleground where survival increasingly depended not only on strength or speed, but on mastering one of nature's most extraordinary inventions, the ability to shape reality through a flash in the dark. Millions of years, darkness had been one of nature's greatest protectors. Ancient oceans concealed countless organisms beneath layers of black water. Small creatures survived by remaining unseen. Vulnerable species drifted through the darkness with a degree of safety that daylight could never provide. Predators certainly existed. Locating prey in such an environment was often difficult. The ocean's shadows worked in favor of those who wished to disappear. Then the rules began to change. The spread of bioluminescence had already transformed communication, attraction, and deception. Organisms were learning that light could influence the behavior of others in surprisingly effective ways. Yet one of the most important discoveries was still waiting to emerge. Predators were about to find a new use for illumination. The realization did not arrive all at once. Evolution rarely moves through sudden revelations. Instead, countless small experiments unfolded across immense stretches of time. Some succeeded, most failed. But eventually, certain predators discovered that producing light could improve their chances of capturing food. That was enough. Once a hunting strategy increases success, even slightly, natural selection begins refining it. Imagine an ancient predator drifting silently through dark water. Nearby, smaller organisms move through the same environment, hidden by darkness. Under ordinary circumstances, locating them would require patience, luck, or highly developed sensory systems. Now something new enters the equation. A faint glow appears. Perhaps it resembles food. Perhaps it resembles another organism. Perhaps it simply attracts curiosity. Whatever the reason, a nearby creature approaches. The distance closes. The trap is sprung. A meal that might otherwise have escaped becomes available. The predator survives. Its descendants inherit the advantage. Over generations, the strategy improves. What began as a simple glow becomes a lure. Elsewhere, different predators experiment with different approaches. Some use sudden flashes to startle hidden organisms into movement. A creature concealed within darkness may remain invisible until fear causes it to. In that instant, its position is revealed. The predator gains valuable information. Again, the strategy succeeds. Again, evolution takes notice. Gradually, the darkness becomes less reliable as a place of refuge. For countless generations, concealment had been one of the most effective defenses available. Remaining unseen often meant remaining alive. Now predators were developing tools capable of penetrating that protection. This shift carried enormous consequences. The ocean was not merely gaining new predators. It was experiencing a change in the balance of power itself. Organisms that had evolved around the assumption of darkness suddenly faced unfamiliar dangers. Traditional survival strategies became less dependable. Behaviors that worked for millions of years could no longer guarantee safety. Pressure spread through entire ecosystems. Every successful hunting innovation created new challenges for prey species. Every adaptation by predators increased the importance of counter-adaptations among potential victims. This is one of the most important principles in evolutionary history. No advantage remains uncontested forever. Whenever one group gains a useful trait, competing organisms face pressure to respond. A stronger predator encourages stronger defenses. Faster prey encourages faster hunters. The process continues endlessly, generating increasing complexity over time. Bioluminescence was becoming part of this cycle. The glow was no longer simply a signal or a display. It had become a weapon. Not a weapon in the traditional sense. No physical damage was inflicted by the light itself. Its power came from information. It altered perception. It revealed opportunities. It exposed weaknesses. In many situations, that was enough to determine life or death. Consequences echoed throughout ancient oceans. Predators carrying their own illumination gained advantages unavailable to earlier generations. The darkness that once concealed prey now contained flashes capable of betraying them. A silent competition was beginning to intensify. Every improvement among hunters forced new responses among the hunted. Every successful strategy inspired new forms of resistance. The ocean was entering a period of escalating conflict where biological light would play an increasingly central role. And as predators continued refining their glowing weapons, prey species were already beginning to develop extraordinary ways of fighting back. The rise of glowing predators transformed ancient oceans into more dangerous places. For countless generations, many organisms had depended upon darkness for protection. Remaining hidden was often enough to avoid becoming a meal. As hunters developed increasingly effective ways of using bioluminescence, concealment alone became less reliable. The ocean was changing. The creatures living within it faced a difficult choice: adapt or disappear. As always, evolution responded. The most fascinating aspect of this response was that many prey species turned to the very same force threatening them. They fought back with light. At first, this seems counterintuitive. If glowing predators had made darkness less safe, why would vulnerable organisms produce even more light? Yet evolution often finds solutions in unexpected places. The answer was not to abandon illumination. The answer was to use it differently. Imagine a small organism pursued through black water by a larger hunter. Escape appears unlikely. Speed offers little advantage. Predator is already close. Then, in an instant, the prey releases a burst of glowing material into the surrounding water. The darkness erupts with light. The predator suddenly loses track of its target. Instead of pursuing the fleeing organism, it encounters a cloud of illumination hanging in the water like underwater smoke. A moment of confusion appears. That moment is enough. Prey escapes. Across millions of years, strategies like this may have spread through ancient ecosystems. Organisms capable of disrupting a predator's perception gained valuable opportunities to survive. Their descendants inherited similar abilities, and those abilities became increasingly refined. Elsewhere, different defensive techniques emerged. Some species may have evolved brilliant flashes designed to overwhelm an attacker's senses. In darkness, sudden illumination can be startling. Predator focused on a target might hesitate when confronted by an unexpected burst of light. Even a brief interruption could alter the outcome of a hunt. Again, survival favored the individuals capable of producing the effect. Again, evolution continued experimenting. Other organisms appear to have discovered an even more sophisticated solution. Instead of simply confusing predators, they redirected attention entirely. Certain species may have produced glowing decoys, points of light positioned away from vulnerable parts of their bodies. A predator attacks the glow. The organism escapes. The deception succeeds. The remarkable thing about these adaptations is that they resemble deliberate strategies, even though no conscious planning is involved. Natural selection performs the role of inventor. Successful solutions remain. Unsuccessful solutions disappear. Over immense spans of time, the process can generate behaviors that appear astonishingly creative. The ocean was becoming a vast evolutionary chess match. Every offensive innovation triggered a defensive response. Every defense encouraged new methods of attack. Predators improved their hunting techniques. Prey developed countermeasures. Hunters adapted again. The cycle repeated endlessly across millions of years. Many of these contests may still be continuing today. Modern deep-sea organisms display defensive bioluminescent behaviors strikingly similar to those imagined in ancient oceans. Clouds of glowing material, dazzling flashes, and misleading signals remain common survival tools in certain environments. Scientists studying these organisms are not simply observing modern adaptations. In many cases, they may be witnessing the latest versions of strategies whose origins stretch back hundreds of millions of years. Realization creates a powerful connection between past and present. The deep ocean still carries echoes of ancient conflicts. Techniques developed in prehistoric darkness continue influencing survival in modern seas. Most importantly, these evolutionary battles reveal something fundamental about life itself. Strength is valuable, speed is valuable, armor is valuable. Information can be equally powerful. A well-timed signal, a convincing illusion, or a moment of confusion can accomplish what physical force sometimes cannot. Survival often belongs not to the largest organism, to the one that controls perception most effectively. As this contest intensified, evolution pushed bioluminescence toward even more astonishing possibilities. The struggle between predators and prey was producing innovations stranger than anyone could have predicted, and among them emerged one adaptation so unexpected that it seemed to violate common sense itself. Some organisms discovered how to disappear by creating light. By now, the story of bioluminescence has become increasingly strange. It began as accidental chemistry evolved into communication. Communication became attraction. Attraction gave rise to deception. Predators transformed light into a hunting tool, while prey developed ingenious defenses in response. Yet evolution was not finished. Its next invention would be one of the most surprising adaptations ever to emerge from the ancient ocean. An adaptation built upon a contradiction. Certain organisms discovered how to become less visible by producing light. At first, the idea seems impossible. Light reveals things. Darkness conceals them. The relationship feels obvious. If an organism wishes to remain hidden, common sense suggests that it should avoid generating illumination altogether. But evolution is not limited by common sense. It is guided by results. And in some environments, the results favored a solution that appears completely backward. To understand how, imagine swimming through relatively shallow ocean waters during daylight. Sunlight penetrates from above, creating a brighter region near the surface. Deeper below, the water becomes progressively darker. Now imagine a predator looking upward. Any organism swimming between that predator and the bright surface creates a silhouette. Even if the creature is small, its dark outline becomes visible against the lighter background above. In effect, the sunlight betrays its position. For countless generations, this presented a challenge. How could an organism avoid standing out against the brightness overhead? Evolution eventually discovered an extraordinary answer. Instead of trying to eliminate the silhouette, some species began producing light along the underside of their bodies. The illumination was carefully matched to the brightness filtering down from above. To a predator looking upward, something remarkable happened. The silhouette disappeared. The organism blended into the surrounding light. Its outline faded. The animal became dramatically harder to detect. This strategy is known today as counter-illumination, and it remains one of the most elegant examples of evolutionary innovation ever discovered. The first time scientists understood how it worked, many experienced the same reaction modern audiences often feel. Then fascination. The adaptation transforms a familiar assumption. Light is no longer merely a way to become visible, it becomes a way to control visibility. Distinction changes everything. Bioluminescence had already demonstrated its value as a signal, a lure, and a defensive tool. Counter-illumination revealed an entirely new possibility. Organisms could manipulate perception itself. They could influence not only what others noticed, but what others failed to notice. The implications spread across ancient ecosystems. Predators searching for prey faced new challenges. Organisms that once stood out against the surface became far more difficult to locate. Species capable of mastering counter-illumination gained powerful survival advantages. Naturally, competitors responded. Evolutionary pressure intensified once again. Every improvement in camouflage encouraged improvements in detection. Every advance in concealment encouraged advances in hunting. The contest continued, but something fundamental had changed. Bioluminescence was no longer a collection of isolated adaptations. It had become a sophisticated toolkit capable of solving remarkably different problems. The same phenomenon that attracted mates could also hide an organism from danger. The same biological process that created communication could create invisibility. One innovation supported countless possibilities. Paradox remains astonishing. Darkness had once been the primary source of concealment in ancient oceans. Now certain organisms were discovering that illumination itself could provide the same protection. Light had become camouflage. Visibility had become invisibility. One of nature's strangest contradictions had become reality. Looking back across millions of years, it becomes clear how far evolution had traveled. The accidental flashes described at the beginning of this story now seem almost simple by comparison. Through endless cycles of competition, adaptation, and refinement, biological light had evolved into something resembling a sophisticated technology. Designed, not planned, yet astonishingly effective, and the journey was far from over. The oceans where these innovations emerged were still touched by sunlight. Beyond them lay a realm where darkness became nearly absolute, a world where biological light would prove more valuable than ever before. The deep ocean was waiting. Until now, the story has unfolded in oceans that still possessed some connection to the world above. Sunlight filtered through the surface. Shadows formed beneath waves. Even the organisms living in darkness existed within environments occasionally touched by distant traces of daylight. However faint those traces became, they remained part of the ecological landscape. Now that connection begins to disappear. The journey moves downward. Far below the surface, beneath the familiar world of sunlight and storms, lies one of the most mysterious environments on Earth. It is a place so vast and remote that humanity has explored only a fraction of it, a realm where darkness is not temporary but permanent. Imagine descending through the ocean. At first, sunlight still reaches the water around you. Colors remain visible, the surface can still be seen above, but with every passing meter the light weakens. Reds vanish first, oranges and yellows fade away. The deeper you travel, the narrower the spectrum becomes. Eventually, even blue light begins to disappear. The ocean grows dim, then darker still. At last, the final traces of daylight vanish completely. The descent continues. The sun is gone. This is the beginning of the deep sea, a world unlike any other on the planet. The conditions seem hostile almost beyond imagination. Temperatures hover near freezing. Pressure increases to levels capable of crushing unprotected structures. Vast distances stretch in every direction. Mountains rise from the seafloor. Valleys plunge into abyssal depths. Yet none of these features can be seen. Darkness covers everything. Not the darkness of a moonless night. Not the darkness of a cave. A deeper darkness. A darkness that has persisted for millions of years without interruption. For organisms entering this realm, the environment presents a fundamental challenge. How does life function where sunlight never arrives? How does an organism locate food, avoid danger, find mates, or navigate its surroundings in a place where vision should be almost useless? At first glance, the deep ocean appears unsuitable for complex life, yet the reality is far more surprising. Rather than suppressing bioluminescence, deep sea became one of its greatest centers of evolution. The reason is simple. In shallow waters, light is helpful. In the abyss, light becomes indispensable. When natural illumination disappears entirely, any organism capable of producing its own light gains extraordinary opportunities. A glow can reveal prey. A flash can send a signal. Pulse can attract a mate. Illumination becomes one of the most versatile tools available in an otherwise invisible world. For immense spans of time, natural selection rewarded those capabilities. The result was extraordinary. Countless deep-sea organisms evolved structures dedicated specifically to producing light. Some developed glowing organs. Others evolved complex arrangements of luminous tissues. Entire lineages embraced bioluminescence as a central part of their survival strategy. A remarkable realization emerges from modern research. In certain regions of the deep ocean, biological light may be encountered more frequently than sunlight itself. The statement sounds impossible at first, yet it reflects a profound truth about life in the abyss. Sunlight never reaches many of these environments. The only illumination comes from living organisms. Every flash, shimmer, pulse, and glow originates from biology rather than the sky. The darkness is alive. This transforms the way the deep ocean must be understood. It is not merely a darker version of shallow water. It is a fundamentally different evolutionary stage. The rules have changed. Strategies that once provided advantages become necessities. Adaptations that were optional near the surface become essential in the abyss. Bioluminescence thrives because it solves problems that few other traits can solve. Communication, navigation, defense, predation, all become easier when an organism can create its own light. The deep ocean therefore acts as a powerful engine of innovation, encouraging new forms of illumination and new ways of using it. Evolution continues experimenting, refining, and expanding upon ideas first developed hundreds of millions of years earlier. And within this eternal darkness, some of the strangest organisms ever to inhabit Earth are beginning to emerge, creatures so unusual that they seem less like animals and more like living pieces of the night itself. In the darkness of the deep ocean, appearance becomes something entirely different. Near the surface, life is shaped by sunlight. Colors, patterns, and forms evolve within an environment where visibility is common. But in the abyss, where darkness has reigned for millions of years, evolution follows stranger paths. The result is a collection of organisms so unusual that they often seem more like creatures from mythology than products of natural history. Imagine drifting through black water, where nothing can be seen beyond a short distance. Suddenly, a small point of light appears ahead. It hangs motionless in the darkness like a distant star. The glow seems harmless. Then the darkness around it moves. The light was never alone, it belonged to a predator. Throughout the deep ocean, countless organisms evolved structures specifically designed to produce illumination. Some carry glowing lures extending from their bodies, gently swaying through the water. Others possess rows of luminous organs that shine like constellations scattered across living flesh. Certain species can generate brief flashes. Others maintain a steady glow for extended periods. To human eyes, these creatures often appear extraordinary. To evolution, they are solutions. Every luminous structure serves a purpose. Every glow exists because it helped ancestors survive. A lure attracts prey, a flash confuses a predator, a pattern identifies a mate. A glow conceals a silhouette. What appears mysterious is often surprisingly practical when viewed through the lens of natural selection. The deep sea became a workshop where evolution tested endless variations of the same fundamental idea. Light could solve problems, and because the problems were numerous, the solutions became equally diverse. One of the most fascinating discoveries made by modern scientists is that many of these light-producing systems evolved independently. Different groups of organisms followed different evolutionary paths, yet arrived at remarkably similar outcomes. Again and again, life rediscovered illumination. Different ancestors, different bodies, different histories, yet similar glowing capabilities emerged repeatedly across unrelated species. This repetition carries an important message. Bioluminescence was not a rare accident preserved by chance. It was a highly successful strategy. Whenever conditions favored it, evolution often found a way to create it. The deep ocean accelerated this process. Predators refined hunting techniques using light. Prey developed defensive signals. Potential mates learned to recognize species-specific patterns. Organisms concealed themselves through carefully controlled illumination. The darkness became a stage upon which countless evolutionary experiments unfolded simultaneously. Some of these experiments continue today. Scientists regularly discover new forms of bioluminescence in species previously unknown to science. Certain organisms produce colors rarely seen elsewhere. Others generate intricate displays that remain only partially understood. Every expedition into the deep ocean seems capable of revealing another variation on the theme. This ongoing discovery highlights an important fact. The remarkable creatures inhabiting the abyss are not isolated curiosities. They are representatives of a vast hidden ecosystem, an ecosystem so large and so poorly explored that significant portions remain unknown even in the modern era. Humanity has mapped distant planets with increasing precision, yet enormous regions of Earth's own deep ocean remain largely unexplored. Countless species may still wait in darkness beyond the reach of observation. Some could possess forms of bioluminescence unlike anything currently documented. The thought is both humbling and exciting. The monsters carrying their own stars are not relics from a completed story. They are part of a living world that continues evolving and surprising us. And perhaps the most intriguing mystery is not the existence of these glowing organisms. It is the sheer number of them. Why did bioluminescence become so widespread? Why did evolution rediscover it again and again across unrelated lineages? Why did so many different creatures arrive at the same extraordinary solution? The deeper scientists look into the abyss, the more difficult those questions become to ignore. Because beneath the diversity of glowing life lies an even larger mystery concerning why living proved so remarkably successful in the first place. By the time life reached the deep ocean, bioluminescence was no longer an experiment. It was a success. The journey had begun with faint chemical reactions hidden inside microscopic organisms drifting through ancient seas. At first, the glow may have been nothing more than an accidental byproduct of survival. Yet over hundreds of millions of years, evolution transformed that accident into one of the most versatile innovations in the history of life. The evidence is impossible to ignore. Became communication. Light became attraction. Light became deception. Light became camouflage. Light became defense. Light became a weapon. Again and again, whenever organisms encountered challenges that illumination could help solve, natural selection refined the ability and pushed it further. This raises an important question. Why was bioluminescence so successful? The answer may lie in one of evolution's most revealing patterns. When a trait appears only once, it is difficult to know whether it represents a rare accident or a truly valuable adaptation. When similar traits evolve repeatedly in unrelated organisms, a different picture emerges. That is exactly what happened with biological light. Scientists studying bioluminescence have discovered something remarkable. The ability appears to have evolved independently many times throughout Earth's history. Different groups of organisms developed their own versions, Different evolutionary lineages arrived at similar solutions despite sharing no recent glowing ancestor. Pattern repeats so often that it cannot easily be dismissed as coincidence. Evolution kept reinventing light, again and again and again. Few biological traits demonstrate such repeated success across such diverse forms of life. The implication is profound. Whenever environmental conditions favored illumination, evolution often found a pathway toward it. The details varied, the chemistry varied, the organisms themselves varied, yet the outcome remained surprisingly consistent. Living light solved important problems. Simple fact may explain its extraordinary persistence. A predator capable of attracting prey gains an advantage. Prey organism capable of confusing attackers gains an advantage. A species able to recognize mates more effectively gains an advantage. An organism capable of disappearing against a bright background gains an advantage. The same basic phenomenon supports countless different strategies. Few adaptations possess such flexibility. Most evolutionary innovations perform a limited number of functions. Bioluminescence proved different. It became a tool that could be modified, expanded, and repurposed across entirely different environments. The deep ocean offers perhaps the clearest demonstration of this success. In regions where sunlight never reaches, biological light often serves as one of the primary forms of interaction. Organisms use it to hunt, communicate, reproduce, navigate, defend themselves, and conceal their presence. Entire ecosystems depend upon the exchange of luminous signals. Without bioluminescence, many deep-sea communities would function very differently. Some might not function at all. This realization transforms the way the story is viewed. Bioluminescence is not a rare curiosity found in a few unusual species. It is one of nature's most effective inventions. It influences the lives of countless organisms across vast stretches of ocean. Its impact extends far beyond individual creatures and into entire ecological systems. The deeper scientists investigate, the more impressive the adaptation becomes. Yet, perhaps the most fascinating consequence of this discovery lies beyond Earth itself. Evolution repeatedly invented living light here. What does that suggest about life elsewhere? Imagine another ocean on another world. A dark environment filled with chemical energy, competition, predators, prey, and millions of years of evolutionary experimentation. Would natural selection eventually discover illumination there as well? Would distant organisms learn the same lessons found in Earth's ancient seas? No one knows, but the possibility is difficult to ignore. The history of bioluminescence suggests that light is not merely a strange biological trick. It may represent one of nature's preferred solutions to certain challenges. And if that is true, then the glowing creatures hidden within Earth's oceans may be telling us something much larger. Perhaps the story of living light is not only about our planet, perhaps it is a clue about how life itself might evolve wherever darkness and opportunity meet. The mystery now extends beyond the ocean floor and toward the stars. For most of this story, the focus has remained firmly on Earth. The journey began in ancient oceans beneath unfamiliar skies. It followed microscopic organisms experimenting with chemistry, predators and prey transforming light into a survival tool, and deep-sea creatures carrying their own illumination through eternal darkness. Every chapter revealed another way evolution reshaped a simple glow into something increasingly extraordinary. Now the story takes a larger step. The ocean remains important, but the horizon expands beyond the planet itself. A question emerges from every flash of living light, and that question reaches all the way into the universe. The mystery begins with a simple observation. Evolution is not careless with complexity. A new adaptation requires time, energy, and opportunity. Most evolutionary experiments fail. Many traits appear briefly before disappearing again, yet certain solutions return repeatedly because they solve problems so effectively that natural selection keeps rediscovering them. Bioluminescence appears to belong to this rare category. Throughout Earth's history, living light evolved independently again and again. Different organisms found different pathways to similar outcomes. The chemistry varied. Bodies carrying the glow varied. The environments varied. The result remained remarkably familiar. Light emerged. This pattern raises an intriguing possibility. Perhaps bioluminescence is not merely a strange feature of earthly life. It is something more universal. Imagine for a moment another world orbiting a distant star, not a barren rock, not a frozen wasteland. A world covered by oceans. Its waters move beneath alien skies. Chemical reactions unfold within its depths. Organisms compete for resources. Predators hunt. Prey evolve defenses, generations pass, millions of years become hundreds of millions. The details differ from Earth, principles remain the same. Life encounters challenges, evolution searches for solutions. What happens next? Would illumination appear there as well? The question is impossible to answer with certainty, but it becomes increasingly difficult to ignore. If light repeatedly proved useful in Earth's oceans, why would similar conditions elsewhere not encourage similar innovations? The idea does not require intelligent beings. It does not require advanced civilizations or technological societies. It only requires life facing familiar evolutionary pressures. Darkness creates problems. Light helps solve them. Natural selection rewards effective solutions. The logic appears surprisingly straightforward. Scientists searching for life beyond Earth often focus on several key ingredients. Liquid water is considered important. Suitable temperatures matter. Chemical resources capable of supporting biological activity receive close attention. Atmospheres are studied. Planetary environments are analyzed. These factors remain essential. Yet perhaps another clue exists. Perhaps researchers should also consider what life tends to do once it begins evolving. The history of Earth suggests that under certain conditions, living organisms may repeatedly discover the value of producing light. Possibility carries fascinating implications. Imagine distant oceans hidden beneath layers of ice. Imagine deep extraterrestrial seas untouched by sunlight. Imagine ecosystems evolving for millions of years in darkness. If bioluminescence truly represents one of nature's preferred solutions, such environments might eventually contain glowing organisms of their own, because they resemble Earth specifically, but because evolution often responds to similar challenges in similar ways. Of course, caution is necessary. No one has discovered alien bioluminescent creatures. No deep space ocean has revealed shimmering life beneath its surface. The evidence simply does not exist. Yet science often advances by asking careful questions before answers become available, and this question remains remarkably compelling. Every glowing organism on Earth represents more than an evolutionary success story. It represents a possibility, a demonstration of what life can achieve when faced with darkness, competition, and opportunity. Seen from that perspective, the deep ocean becomes something unexpected. A preview, not necessarily of what exists elsewhere, of what might be possible elsewhere. The tiny flashes appearing beneath Earth's waves suddenly feel larger than themselves. Each one becomes part of a broader mystery, a clue hidden within biology, a signal emerging from the darkness, a reminder that if evolution discovered living light so many times here, the universe may contain more glowing worlds than anyone has yet imagined. And once that possibility enters the story, another question immediately follows. If life capable of producing light could exist elsewhere, where should we begin looking for it? If the story of bioluminescence teaches anything, it is that life can thrive in places once thought impossible. Generations many people assumed that sunlight was essential for complex ecosystems. The idea seemed reasonable. On the surface of Earth, nearly every food chain depends directly or indirectly on energy from the sun. Remove sunlight, and the entire system appears destined to collapse. Then scientists explored the deep ocean. What they discovered changed everything. Far beneath the reach of daylight, entire communities survived without any connection to the surface world. Organisms gathered around hydrothermal vents. Chemical energy replaced sunlight as the foundation of life. Ecosystems flourished in perpetual darkness. The lesson was profound. Life does not always require sunlight. It requires energy. That realization transformed the search for life elsewhere in the universe. Suddenly, worlds that once seemed unpromising became far more interesting. Imagine standing on the surface of a distant, icy moon. The landscape appears barren. Frozen plains stretch toward the horizon beneath a cold and silent sky. No forests grow there. No oceans are visible. Nothing about the environment suggests abundant life. Yet appearances can be deceptive. Beneath the ice may lie vast oceans, entire seas hidden from view. Some of these oceans could contain more water than all of Earth's oceans combined. Protected beneath thick shells of ice, they remain isolated from the harsh conditions above. Darkness dominates these environments. In some cases, sunlight may never penetrate their depths at all. At first glance, such places seem inhospitable. Then the comparison with Earth's deep ocean begins to emerge. Both environments contain darkness, both may contain chemical energy, may possess geological activity capable of driving complex reactions. Heat from planetary interiors could interact with water and minerals, creating chemical gradients similar to those found around deep-sea vents on Earth. The similarities become increasingly difficult to ignore. If life can survive in Earth's abyss, perhaps similar conditions elsewhere could support it as well, and if life evolves within those hidden oceans, it may encounter challenges remarkably similar to those faced by ancient organisms on our own planet. Finding food, avoiding predators, locating mates, communicating across darkness, navigating environments where visibility is almost non-existent. The deeper the comparison goes, the more intriguing bioluminescence becomes. On Earth, some of the highest concentrations of glowing organisms are found in the darkest habitats. The absence of sunlight did not discourage the evolution of light. In many cases, it encouraged it. Darkness created opportunities. Evolution responded. Could the same thing happen elsewhere? No one knows. Yet the possibility follows naturally from what has already been observed on Earth. If alien oceans contain life, and if that life experiences similar evolutionary pressures, producing light may prove just as useful there as it has here. The thought is astonishing. Entire ecosystems glowing beneath frozen worlds, predators carrying luminous lures through extraterrestrial waters, organisms exchanging signals in oceans no human has ever seen. Not because they copied Earth, because evolution repeatedly discovers effective solutions when confronted with similar problems. Of course, these ideas remain speculative. No glowing alien creature has been found, no hidden ocean beyond Earth has revealed evidence of bioluminescent life. Yet speculation grounded in evidence often points science toward important questions. And the evidence from our own planet is compelling. Again and again, darkness encouraged innovation. Again and again, life discovered the value of illumination. Bioluminescence therefore becomes more than a biological curiosity. It becomes a clue about what evolution is capable of achieving. A reminder that when organisms encounter darkness, one of the most successful responses may be to create light of their own. The universe suddenly feels larger and more mysterious. Not because we know glowing oceans exist elsewhere, because we can now imagine how they might. Yet before searching too far beyond Earth, another truth demands attention. Humanity still knows surprisingly little about the glowing world hidden beneath its own oceans. After traveling across imaginary oceans hidden beneath distant worlds, it is tempting to keep looking outward. The universe offers no shortage of mysteries. Countless planets orbit distant stars. Frozen moons conceal secrets beneath their icy surfaces. Vast regions of space remain unexplored. The possibility of life beyond Earth continues to capture human imagination for good reason. Yet there is an irony hidden within this search. Before humanity can fully understand alien oceans, it must confront a humbling fact about its own world. Much of Earth remains unexplored. The statement sounds surprising at first. Modern civilization is surrounded by advanced technology. Satellites circle the planet. Spacecraft travel beyond the solar system. Maps of distant landscapes continue improving every year. And yet beneath the oceans, enormous regions remain largely unknown. The deeper the water becomes, the more mysterious the planet itself appears. Human beings have walked on the moon. Robotic explorers have traveled across distant worlds. Detailed images exist of landscapes hundreds of millions of kilometers away. Meanwhile, vast portions of Earth's deep ocean have never been directly observed. The contrast feels almost unbelievable. One of the greatest frontiers on the planet lies hidden beneath familiar waves. For scientists studying bioluminescence, this reality carries profound implications. Every expedition into the deep ocean seems to uncover something unexpected. New species appear. Strange behaviors emerge. Organisms are discovered in places once considered too hostile for complex life. Environments thought to be barren reveal surprising forms of activity. The pattern repeats often enough to suggest something important. The story of living light is far from complete. Researchers continue finding organisms capable of producing illumination in ways previously unknown. Some generate unusual colors. Others employ strategies unlike anything documented before. Entire branches of the evolutionary story remain fragmented, waiting to be pieced together. The deeper humanity explores, the larger the mystery becomes. One reason for this uncertainty is scale. The deep ocean is immense. Its darkness conceals mountain ranges, valleys, plains, and ecosystems stretching across extraordinary distances. Even with modern technology, investigating these environments remains difficult. Exploration requires specialized equipment, considerable resources, and a willingness to venture into conditions that challenge both machines and people. As a result, Many scientists believe that a substantial portion of deep-sea life has yet to be documented. The exact number remains unknown. No one can confidently say how many species remain undiscovered. What researchers do know is that new organisms continue appearing with remarkable regularity. Each discovery raises the possibility that countless others remain hidden beyond current observation. Some of them may possess forms of bioluminescence unlike anything humanity has encountered. The thought is remarkable. After centuries of scientific inquiry, entirely new evolutionary experiments may still be unfolding in darkness beneath the ocean floor. Ancient biological innovations continue operating beyond human awareness, just as they have for millions of years. In a sense, the deep ocean resembles a living archive. Every glowing organism represents a chapter in a story that began long before humanity existed. Some chapters have been read, others remain sealed within darkness. This realization restores a sense of mystery to the present moment. It is easy to imagine exploration as something belonging to the past. The age of discovery feels distant, associated with old maps and unfamiliar coastlines, yet beneath Earth's oceans, genuine discovery remains very much alive. There are still places where no human eyes have looked. Still species waiting to be found. Still questions without answers. The search for living light, therefore, becomes more than a scientific investigation. It becomes a reminder of how much remains unknown about the world we already inhabit, and perhaps that is the most important lesson. Before deciding whether glowing ecosystems exist beneath alien oceans, humanity must first understand the glowing ecosystems hidden beneath its own seas. The story is not finished. The ancient experiments of evolution continue today, deep beneath the waves. And having explored where bioluminescence exists, the next mystery becomes more personal. How did living light change the course of life itself? For much of this story, bioluminescence has appeared as a remarkable adaptation. It helped organisms survive. It allowed them to communicate, hunt, attract mates, avoid predators, and navigate darkness. Again and again, living light emerged as one of evolution's most successful inventions. Yet there is another possibility hidden beneath all of these developments. What if bioluminescence did more than help organisms interact with their environment? What if it changed how life perceived the environment itself? Understand this idea. It helps to return to the ancient oceans where glowing signals first became common. At the beginning, flashes were relatively rare. A pulse of light appearing in darkness represented an unusual event. But as bioluminescence spread through ecosystems, flashes became increasingly important. And whenever something becomes important, evolution pays attention. Imagine a small organism drifting through dark water. Nearby, another creature produces a faint glow. If the first organism can detect that signal, it gains information. The light might reveal food, it might reveal danger, it might reveal a potential mate. Regardless of the specific outcome, information carries value. An organism capable of detecting light slightly better than its competitors gains an advantage. Advantage may be small, but evolution does not require large advantages. Small advantages are enough. Over generations, individuals better at recognizing flashes survive more successfully. Their descendants inherit similar sensory abilities. Slowly, visual systems improve. Then something interesting happens. As eyes become more effective, glowing signals become more valuable. Brighter flash is easier to notice. A more precise pattern becomes easier to distinguish. Organisms producing better signals gain advantages of their own. The cycle begins feeding itself. Better signals reward better eyes. Better eyes reward better signals. Each improvement encourages another. Over immense spans of time, process creates what biologists often describe as an evolutionary feedback loop. Neither side develops in isolation. Signalers influence observers. Observers influence signalers. The relationship drives increasing complexity throughout entire ecosystems. Consequences can be profound. Predators equipped with improved vision locate prey more effectively. Prey species capable of recognizing warning signals avoid danger more successfully. Mates become easier to identify. Predators become easier to monitor. Light begins shaping behavior at every level. The ocean gradually transforms into a world where seeing becomes increasingly important. This possibility has led some evolutionary biologists to propose a fascinating idea. Perhaps interactions involving light contributed significantly to the development of advanced visual systems. The suggestion does not mean that bioluminescence alone created vision. Eyes evolved for many reasons across many environments. Yet living light may have acted as a powerful evolutionary incentive. encouraging organisms to become more sensitive to visual information. The theory remains difficult to prove conclusively, but it offers a compelling perspective. Instead of viewing bioluminescence as merely a consequence of evolution, it becomes a cause of further evolutionary change. The glow influences the observer. The observer changes. The change alters the ecosystem. New pressures emerge. Evolution responds again. Began as a chemical reaction inside ancient cells now influences the development of sensory systems across entire communities of organisms. The idea transforms the role of bioluminescence within the story. Glowing organisms are no longer passive participants adapting to their surroundings. They become active forces shaping the future of life around them. Every flash carries consequences extending beyond the individual producing it. Every signal helps determine which sensory abilities are rewarded. Every improvement changes the nature of survival itself. Seen from this perspective, the deep ocean becomes more than a habitat filled with glowing creatures. It becomes an evolutionary conversation between light and perception, a conversation that may have continued for hundreds of millions of years. And as visual systems became increasingly sophisticated, the relationship between illumination and survival grew even more complex. The glow no longer simply revealed information. It began participating in one of the longest and most influential competitions in the history of life, contest between those who produced light and those who learned to see it. Once organisms learned to produce light, and once other organisms learned to detect it, a new kind of rivalry emerged within the oceans. Unlike many evolutionary conflicts, this one was not fought primarily through strength, speed, or size. It was fought through information. For millions of years, glowing signals and visual systems pushed each other forward in a contest with no obvious ending. Every improvement on one side created pressure for improvement on the other. Every successful innovation eventually inspired a response. The cycle never stopped. Imagine an ancient predator capable of detecting faint flashes more effectively than its competitors. Suddenly, signals that once remained hidden become visible. Prey organisms that relied upon those signals are now easier to locate. Predator gains an advantage. For a time. Soon, natural selection begins favoring prey that produce different patterns, weaker signals, more deceptive displays. Some may alter the timing of their flashes. Others may evolve better camouflage. Few might abandon previously successful strategies altogether. Now the prey gains an advantage, again only for a time. Predators respond. The contest continues. This pattern appears repeatedly throughout evolutionary history. Success creates opportunity. It also creates vulnerability. The moment an adaptation becomes valuable, competing organisms begin searching for ways to overcome it. Bioluminescence was no exception. As visual systems improved, glowing organisms faced increasing pressure to become more sophisticated. Simple signals that once worked effectively gradually lost their usefulness. New approaches became necessary. Signals grew more complex. Patterns became more distinctive. Camouflage became more refined. Some organisms evolved illumination designed specifically to avoid detection. Others developed flashes visible only under particular conditions. Certain species may have adopted displays that carried multiple layers of information simultaneously. Meanwhile, visual systems continued improving. Eyes became more sensitive. Detection became more precise. Organisms learned to interpret increasingly subtle differences in brightness, timing, and pattern. Relationship resembles an endless conversation between two evolutionary forces. One side creates signals. The other side learns to read them. Then the signals change. Then the readers adapt. The exchange repeats across countless generations. Viewed over short periods of time, the changes appear minor. Viewed across hundreds of millions of years, the cumulative effect becomes extraordinary. Entire ecosystems transform. Evolution begins to resemble an inventor constantly refining old designs while experimenting with new ones. A successful strategy emerges. It spreads through populations. Competitors develop responses. The original strategy becomes less effective. New variations appear. Process never settles. It never reaches perfection. That may be one of the most important lessons hidden within the story of bioluminescence. Evolution does not work toward a final goal. There is no ultimate version of a glowing signal, no perfect eye, no finished design. Every success simply creates new challenges. Every advantage eventually encounters opposition. The contest between light and vision illustrates this principle beautifully. Neither side wins permanently. Neither side achieves complete dominance. Instead, both continue changing in response to one another. Even today, the rivalry remains visible. Modern bioluminescent organisms display behaviors that appear remarkably sophisticated. Some generate intricate patterns, others manipulate visibility with extraordinary precision. Many possess adaptations that seem perfectly suited to their environments. Yet these adaptations are not endpoints, they are chapters. The latest chapters in a story that began hundreds of millions of years ago. Every flash observed in the deep ocean today carries traces of ancient evolutionary struggles. Hidden within each signal are echoes of predators, prey, competitors, and environmental pressures stretching back into deep time. The battle continues because the conditions that created it continue. Darkness still exists, information still matters, survival still depends upon the ability to perceive and influence the surrounding world. The result is a contest without a final victor. A rivalry capable of lasting longer than entire mountain ranges, continents, and climates. Perhaps the most remarkable outcome of this endless competition was not any individual adaptation. It was something larger, something that emerged when countless organisms began exchanging, interpreting, concealing, and manipulating information through light. Over time, entire ecosystems started functioning in ways that resembled vast networks of communication. The ocean was becoming more than a collection of species. It was becoming a system built around information itself. When most people imagine communication, they think of individual messages. One organism sends a signal, another receives it. Information travels from one point to another, and the interaction ends there. The history of bioluminescence reveals something far more complex. Over millions of years, living light may have transformed entire ecosystems into interconnected networks where information moved continuously through darkness, influencing organisms that never directly touched one another. The change was subtle at first. A flash appears, another organism reacts. Reaction triggers a second response elsewhere, then a third, then a fourth. Began as a simple exchange gradually becomes part of a larger system. Imagine an ancient predator attacking a small prey organism. In the struggle, the prey releases a burst of light. Nearby creatures detect the signal. Some flee, others become alert. Predators in the area adjust their behavior. Organisms that were never directly involved in the original encounter suddenly possess new information. The effects spread outward. One flash changes many behaviors. The darkness carries information farther than physical contact ever could. This principle likely became increasingly important as bioluminescence spread through marine environments. The more organisms relied upon visual signals, the more opportunities existed for information to move between them. Over time, ecosystems became more responsive. Events occurring in one location could influence behavior elsewhere. Warning signal might help nearby organisms avoid danger. A hunting signal might attract competitors. A mating display might alter the movement of individuals throughout an area. The consequences extended beyond single species. Entire communities became linked through information. The concept sounds surprisingly modern, yet its foundations may be extraordinarily ancient. Long before advanced intelligence evolved, organisms were already interacting with information-rich environments. They were responding to signals, interpreting patterns, and modifying behavior based upon events occurring beyond their immediate surroundings. No conscious understanding was required. Natural selection simply rewarded responses that improved survival. The result was a world becoming increasingly connected. Researchers studying modern marine ecosystems occasionally observe phenomena that hint at complexity. Certain environments appear almost alive with communication. Flashes ripple through darkness. Signals spread between organisms. Behaviors shift in response to events occurring nearby. The ocean begins to resemble a living information system. Not a system designed by intention. A system assembled gradually through evolution. Every species contributes signals. Every species responds to signals. Together they create networks extending across entire ecosystems. The deeper one thinks about this process, the more remarkable it becomes. Bioluminescence did not merely help individual organisms solve specific problems. It altered the way ecological communities functioned. The flow of information became faster, broader, and more influential. Organisms gained the ability to affect one another across distances that would otherwise remain impossible in darkness. Life itself became more interactive, more responsive, more dynamic. The transformation carries echoes of much larger developments that would come later in Earth's history. Human societies depend upon communication networks. Information moves between individuals, influencing behavior across enormous distances. Modern technology expanded these capabilities dramatically. Yet, the basic principle is ancient. Information changes outcomes. And in many marine ecosystems, light became one of the most effective ways to distribute that information. Seen from this perspective, bioluminescence appears far more significant than a simple biological adaptation. It becomes an ecological force capable of reshaping relationships throughout entire environments. The journey from accidental chemistry to interconnected ecosystems is astonishing. A faint cellular reaction produced a flash. Flash became useful. The usefulness became communication. Communication became networks. And those networks influenced the course of evolution itself. The scale of the transformation is difficult to overstate. What began as microscopic chemistry eventually contributed to one of the most influential communication systems ever created by life. The oceans became filled with messages. Signals moved through darkness. Information connected organisms across space and time. And all of it emerged long before intelligence, language, or civilization appeared. The story therefore raises a final question. If bioluminescence proved so useful, so adaptable, and so influential throughout Earth's history, why did evolution continue choosing it again and again? Why, after hundreds of millions of years, does living light remain one of nature's most successful inventions? That mystery waits beyond the darkness. The question has been waiting quietly in the background since the beginning of this story. It appeared when the first accidental flashes emerged inside ancient cells. It followed the rise of communication, deception, camouflage, and deep-sea survival. It lingered beneath every discovery, every adaptation, and every evolutionary innovation. Now it returns. Why does evolution keep choosing light? At first glance, the answer seems obvious. Bioluminescence is useful. Usefulness alone does not explain its remarkable success. Many useful adaptations appear once and remain limited to a handful of species. Others vanish entirely as environments change. Evolution is filled with innovations that seemed promising for a time before fading into history. Bioluminescence followed a different path. Again and again, across hundreds of millions of years, unrelated organisms discovered ways to glow. Fish evolved it, jellyfish evolved it, squid evolved it, crustaceans evolved it, microscopic organisms evolved it. Entirely different branches of life arrived at similar outcomes despite traveling along separate evolutionary roads. The repetition is extraordinary, and it becomes even more impressive when one considers the cost. Producing light requires energy. Every living organism operates within strict limits. Energy spent in one place cannot be spent elsewhere. Resources devoted to glowing are resources unavailable for growth, movement, reproduction, defense. Evolution is not generous. Wasteful traits rarely survive for long. If bioluminescence repeatedly persisted despite these costs, benefits must have been substantial. That realization changes the perspective. The question is no longer why some organisms evolved light. The deeper mystery is why so many did. Imagine evolution as a relentless problem solver. Every species faces challenges: finding food, avoiding predators, reproducing successfully, navigating environments filled with competition and uncertainty. Different organisms discover different solutions. Some evolve speed, others evolve armor. Some rely on camouflage, others depend upon venom, intelligence, or strength. Bioluminescence belongs within this collection of solutions, but with one important difference. Versatility is almost unmatched. The same basic capability can be adapted for countless purposes. The glow can attract prey, it can repel predators, it can reveal information, it can conceal information, it can identify mates, it can disguise an organism's position, it can transform darkness from a limitation into an opportunity. Few evolutionary innovations possess such flexibility. This may explain why natural selection kept returning to it. Whenever environmental conditions favored illumination, evolution often rediscovered a way to create it. The chemistry differed, the organisms differed, the circumstances differed, yet the outcome remained familiar. Light emerged because it worked. This idea leads to one of the most important principles in biology. Evolution does not reward traits because they are beautiful. It does not preserve adaptations because humans find them fascinating. Natural selection favors results. If a trait improves survival or reproduction, it spreads. If it fails, it disappears. Bioluminescence survived one of the most demanding tests imaginable: time. Hundreds of millions of years of competition, environmental change, extinction events, and evolutionary experimentation failed to eliminate it. Instead, the trait expanded into new habitats, new species, and new ecological roles. The persistence itself is evidence. Living light solved important problems, and it solved them repeatedly. Seen from this perspective, bioluminescence no longer appears as a biological curiosity hidden within the ocean. It becomes one of nature's most successful inventions, an innovation capable of reshaping ecosystems across vast stretches of time. The glow that began as accidental chemistry evolved into a force influencing communication, behavior, perception, and survival throughout the living world. Yet despite everything scientists have learned, an uncomfortable truth remains. Many mysteries still surround bioluminescence. Researchers understand more than ever before, but new discoveries continue raising new questions. Strange organisms appear in unexplored environments. Unexpected mechanisms challenge existing assumptions. Entire chapters of the story remain incomplete. The deeper humanity investigates living light, the more it becomes clear that some of the greatest mysteries may still be waiting in the darkness. After everything humanity has learned about bioluminescence, it would be easy to assume the mystery has largely been solved. Scientists understand many of the chemical reactions involved. Researchers have identified important molecules, documented countless glowing species, and observed bioluminescent behaviors in environments ranging from shallow coastal waters to the deepest parts of the ocean. The story seems familiar. Mystery appears. Science investigates. Answers emerge, yet the reality is more complicated. The deeper researchers look into living light, the more questions they uncover. In many ways, bioluminescence remains one of nature's most intriguing puzzles. Consider something as seemingly simple as color. Why do certain organisms produce blue light while others generate green, yellow, even reddish glows? Some explanations exist. Different colors travel through water differently. Certain wavelengths may be easier for specific organisms to detect. Environmental conditions influence which signals prove most effective, yet many details remain uncertain. Scientists can often describe what happens without fully understanding why evolution selected one solution instead another. The questions continue. How many forms of bioluminescence exist that humanity has not yet discovered? The answer is unknown. Every year, researchers encounter organisms displaying unexpected behaviors or unfamiliar biological mechanisms. Species found in isolated environments occasionally reveal entirely new approaches to producing light. Possibility remains that countless undiscovered examples still wait in darkness. Other mysteries reach even further into the past. Which evolutionary pathways produce the earliest glowing organisms? How many independent origins of bioluminescence occurred throughout Earth's history? Did certain chemical systems evolve multiple times? Did some disappear completely before leaving descendants behind? The evidence becomes increasingly difficult to interpret the farther back one travels. Ancient flashes leave few traces. Deep time conceals many of its secrets. Yet perhaps the most fascinating aspect of scientific investigation is that uncertainty does not represent failure. It represents opportunity. Science rarely advances by replacing mystery with complete certainty. More often, discoveries reveal additional layers hidden beneath previous assumptions. Every answer opens new questions. Every breakthrough exposes fresh territory waiting to be explored. Bioluminescence illustrates this pattern beautifully. Some of the most important discoveries in the field have occurred surprisingly recently. Organisms once believed to be understood continue revealing unexpected behaviors. Researchers studying familiar species occasionally uncover mechanisms no one anticipated. Entire categories of interaction emerge from observations made in environments that remained inaccessible for most of human history. Again and again, nature proves more inventive than expected. A scientist enters an expedition believing the basic story is known. The ocean responds with something new, a different signal, a different behavior, a different solution. The cycle repeats. What makes this process so captivating is that bioluminescence sits at the intersection of multiple mysteries. It involves chemistry, evolution, ecology, communication, perception, and behavior. Understanding one aspect often reveals complexity in another. The glow itself remains familiar. The reasons behind it grow increasingly intricate. This recurring theme has followed the documentary from the beginning. The deeper humanity looks into nature, the more astonishing nature becomes. Ancient oceans once appeared simple until hidden ecosystems were discovered. Deep-sea darkness seemed empty until it revealed countless glowing organisms. Bioluminescence looked like a curiosity until it became a force shaping entire evolutionary histories. Each layer concealed another. Each answer led further inward. And perhaps the greatest surprise is that the process continues. The story of living light remains unfinished. Researchers are still exploring. New species are still being found. New questions are still emerging. Some of the most important secrets may not belong to the past at all. They may be waiting in unexplored regions of the present. Somewhere in the darkness, another discovery waits, another unexpected flash, another clue. And as those mysteries accumulate, point toward an even larger question. What does the existence of bioluminescence ultimately reveal about life itself? Reflection carries the story toward its final destination. The story began in darkness, not the darkness of space, but the darkness beneath ancient oceans. A world hidden beneath unfamiliar skies where life struggled, adapted, and searched for ways to survive. At first, the mystery seemed straightforward. Why would any organism spend precious energy creating light? The answer turned out to be far larger than the question. Across this journey, the glow evolved from a curious chemical reaction into something extraordinary. It shaped communication, influenced perception, transformed hunting strategies, altered ecosystems, and perhaps even helped guide the development of vision itself. Yet looking back, another pattern becomes impossible to ignore. Bioluminescence is not merely a story about light, it is a story about possibility. Again and again, life encountered limitations. Again and again, those limitations became opportunities. The earliest organisms faced chemical challenges within their own cells. Reactions that may have begun as biological necessities eventually produced faint flashes. Those flashes acquired value. Value encouraged adaptation. Adaptation generated innovation. Ancient chemistry became biology. Biology became communication. Communication became strategy. Strategy reshaped evolution. Each step emerged from the one before it, creating consequences that no organism could have predicted when the journey began. This pattern extends far beyond bioluminescence itself. Throughout Earth's history, evolution repeatedly transformed obstacles into advantages. Wings emerged from structures that originally served other purposes. Complex eyes developed from simple light-sensitive cells. Countless innovations began as modest solutions before becoming something far more significant. Bioluminescence belongs among these remarkable transformations. Darkness appeared to impose limits. Life responded by creating illumination. Response was so successful that it spread across oceans, ecosystems, and entire branches of the evolutionary tree. Organisms separated by vast stretches of time and ancestry independently discovered the same fundamental idea. If darkness prevents visibility, create visibility. If information is difficult to obtain, generate information. If the environment lacks light, become the source of light. The simplicity of the solution makes its consequences even more astonishing. Today, every glowing organism serves as evidence of nature's creativity. Flash in the deep sea represents more than a biological function. It represents millions of years of experimentation, refinement, failure, and success. It represents an answer discovered by evolution to a challenge imposed by the environment. And the answer continues working. Far beneath the surface of modern oceans, countless organisms still produce light. Predators hunt using luminous lures. Prey release glowing defenses. Species communicate through flashes invisible to human eyes. Ancient strategies continue unfolding in real time. The process never stopped. It simply continued beyond human awareness. There is something deeply humbling about that realization. Long before humanity appeared, organisms were already shaping darkness with light. Long before anyone could appreciate beauty, glowing displays illuminated ancient seas. Long before intelligence wondered about the universe, evolution was conducting experiments whose results still survive today. Predates civilization. It predates mammals. It predates forests. It reaches back into an age so distant that the world itself would be almost unrecognizable. And yet the phenomenon remains. A flash appears. A signal travels through darkness. Another organism responds. The cycle continues. Perhaps this is why bioluminescence feels so captivating. It connects chemistry to biology, biology to evolution, and evolution to something larger. It reveals how simple beginnings can generate extraordinary outcomes when given enough time. The deeper meaning of the story may not lie in the light itself. It may lie in what the light represents. Resilience, adaptation, creativity, the endless ability of life to find solutions where none seem to exist. Perhaps the greatest mystery is not why some organisms learned to glow, Perhaps the greater mystery is why life never stopped trying, and as the story moves toward its final chapters, attention turns from the distant past to the present, where the legacy of those ancient flashes continues shaping the modern world in ways few people ever notice. The story now returns to the present. After traveling across ancient oceans, witnessing evolutionary experiments unfold over hundreds of millions of years, and exploring the possibility of glowing worlds beyond Earth, it is easy to imagine bioluminescence as something belonging primarily to the distant past, but the glow never disappeared. It never became a relic. It never stopped. At this very moment, while cities shine beneath electric lights and most of humanity sleeps, countless organisms are producing their own illumination beneath the ocean's surface. The same evolutionary story that began in prehistoric seas continues quietly around the world. The ancient flashes are still here. They simply wear modern forms. In the deepest trenches of the ocean, bioluminescent fish drift through darkness that remains almost unchanged from the environments inhabited by their distant ancestors. Along coastlines, microscopic organisms illuminate waves with shimmering blue light. Coral ecosystems host species that communicate, hunt, and defend themselves using luminous signals. Throughout the open ocean, jellyfish, squid, crustaceans, and countless other organisms continue employing strategies refined across unimaginable spans of time. The settings may differ. Principles remain familiar: communication, camouflage, predation, defense, survival. The same challenges that shaped ancient bioluminescence continue influencing life today. This continuity creates a remarkable perspective. Observing a glowing organism in the modern world, it is tempting to focus on the present moment. A flash appears. A signal moves through the water. The event feels immediate and contemporary, yet the reality extends much deeper. Flash represents an evolutionary solution tested across hundreds of millions of years. It carries traces of countless generations that survived because illumination provided an advantage. Behavior being observed today may be linked to strategies first developed long before familiar animals existed. In some cases, the connection reaches astonishing distances into the past. The glow seen beneath modern oceans may closely resemble flashes produced before dinosaurs walked across continents. Certain biological systems have persisted through changing climates, shifting oceans, mass extinctions, and the rise and fall of entire groups of organisms. The world transformed repeatedly around them. The light remained. This realization introduces one of the most fascinating aspects of evolution. Not all history disappears. Some of it survives. Ancient innovations continue operating in living organisms long after the environments that shaped them have changed. Evolution preserves successful solutions, refining them while carrying them forward through time. Bioluminescence may be one of the most impressive examples. Every glowing jellyfish becomes a living fragment of evolutionary history. Every luminous squid becomes a messenger from deep time. Every microscopic flash within a coastal wave represents a story stretching backward across ages that exceed human comprehension. The organisms themselves are modern. The strategies they employ are ancient. Viewed this way, the oceans become something extraordinary. They are not merely habitats, they are archives. Living collections of biological ideas that survived because they worked. Innovations tested by natural selection and preserved through persistence rather than intention. Entire civilizations have appeared and vanished during the period bioluminescence has existed. Languages emerged. Empires rose and fell. Technologies transformed human society. Meanwhile, beneath the waves, ancient luminous systems continued functioning. Quietly, consistently, almost unnoticed. The story therefore never truly ended. The chapters described throughout this documentary are not confined to the past. They continue unfolding every day in oceans around the world. Evolutionary experiments that began hundreds of millions of years ago remain active. Participants in modern ecosystems, the glow survives because the challenges it addresses survive. Darkness still exists, predators still hunt, prey still evade, organisms still search for mates, and the need remains. So does the solution. Perhaps the most surprising part of the story is that humanity has benefited from these ancient innovations in ways few people ever realize. The light that survived deep time would eventually illuminate something far beyond the ocean itself. For most of its history, bioluminescence served only the organisms that possessed it. A flash frightened a predator, a glow attracted a mate. A signal carried information through darkness. The benefits remained confined to the living creatures that produced the light. or so it seemed. Then humanity began paying closer attention. At first, scientists studied glowing organisms for the same reason many people find them fascinating. They were unusual, beautiful, mysterious. Their ability to create light appeared almost magical when compared to the familiar forms of life found on land. Yet the deeper researchers investigated, the more they discovered something extraordinary. The glow was not merely a curiosity, it was a tool, and nature had spent hundreds of millions of years refining it. This realization opened an unexpected chapter in the story. The same biological systems that helped ancient organisms survive in dark oceans contained information that could be useful far beyond the sea. Molecules originally shaped by evolutionary pressures revealed capabilities that scientists could adapt for entirely different purposes. Slowly, laboratories around the world began borrowing nature's inventions. The process reflects a pattern seen throughout human history. People often assume technology emerges from human creativity alone, yet many of humanity's most effective solutions originated elsewhere. Inspired flight, plant structures inspired engineering designs. Natural systems repeatedly offered ideas that researchers transformed into new applications. Bioluminescence joined this tradition. Scientists discovered that the chemistry responsible for living light could reveal processes otherwise hidden from observation. Suddenly, biological activity occurring deep inside cells became easier to track. Events invisible to the naked eye could be illuminated, measured, and studied. Quite literally, life began helping humanity see life. The irony is remarkable. Molecules that evolved to help marine organisms survive predators eventually helped researchers investigate diseases. Biological mechanisms that once carried signals through dark oceans became tools for exploring the inner workings of living systems. Ancient adaptations found new purposes. Evolution had already performed much of the difficult work. Humanity simply learned how to use the results. This does not mean the transition happened quickly. Scientific breakthroughs rarely arrive in dramatic moments. They emerge gradually through observation, experimentation, and persistence. Researchers spent years studying glowing organisms, trying to understand the principles behind their remarkable abilities. The effort proved worthwhile. Some of the most important biological discoveries of recent decades were influenced by knowledge gained from organisms producing light. The details differ from one field to another, but the underlying theme remains consistent. Nature solved problems long before humans recognized the value of those solutions. The lesson extends beyond bioluminescence itself. Throughout evolutionary history, countless adaptations emerged because they improved survival in specific environments. The organisms involved had no awareness of future applications. They were not evolving for science, medicine, or technology. They were simply surviving. Yet survival generated innovations whose significance extended far beyond their original purpose. A glowing marine organism drifting through prehistoric waters could never have imagined that its descendants would someday contribute to human understanding of life itself. The connection spans an astonishing distance. Millions of years separate the ancient oceans where bioluminescence evolved from the laboratories where scientists study it today. And yet the link remains direct. The same evolutionary process connects both worlds. What began as chemistry became adaptation. Adaptation became survival. Survival became knowledge. Knowledge became discovery. The chain continues. Perhaps that is one of the most beautiful aspects of the story. Evolution often creates possibilities long before anyone understands their importance. Solutions emerge first. Their broader significance becomes visible only much later. Bioluminescence demonstrates this principle perfectly. Ancient organisms developed light because it helped them navigate darkness. Humanity eventually learned that the same light could illuminate mysteries of its own. Yet even this remarkable contribution may not represent the deepest lesson hidden within the story. Beyond science, technology, and discovery lies a more profound insight about life itself. An insight revealed by every glowing organism that has ever existed. As this journey approaches its final chapter, it becomes possible to step back and view the story from a greater distance. The details remain fascinating: the chemistry, the glowing predators, the hidden signals moving through ancient oceans, the strange creatures carrying their own light through the abyss. Each chapter revealed a different piece of the puzzle. Beneath those details lies something larger. A pattern, a lesson hidden within the darkness itself. The story began with a mystery that seemed almost impossible to answer. Why would evolution favor something as costly as bioluminescence? Producing light requires energy. Energy is valuable. Every resource devoted to glowing must come from somewhere. At first glance, the adaptation appears inefficient. Life should have avoided it, and yet life did the opposite. Again and again, across hundreds of millions of years, organisms discovered ways to make light useful. Different species arrived at similar solutions despite facing different circumstances. The glow spread not because it was easy, but because it worked. That distinction matters. Evolution rarely follows predictable paths. If it did, many of nature's most remarkable innovations would never have appeared. Wings seem improbable until they evolve. Eyes seem extraordinarily complex until gradual changes make them possible. Bioluminescence belongs within the same category. The adaptation should have been difficult. It should have been costly. Yet life repeatedly found reasons to embrace it. The deeper one examines this history, the clearer a broader truth becomes. The significance of bioluminescence may not lie in the light itself. It may lie in what the light represents. Throughout the documentary, a recurring pattern emerged. Organisms encountered challenges that appeared limiting. Darkness restricted visibility. Distance separated individuals. Predators created danger. Environmental pressures threatened survival. Each obstacle seemed capable of reducing possibilities. Instead, those obstacles created new ones. Darkness became communication. Isolation became connection. Danger became innovation. The very conditions that appeared restrictive encouraged entirely new forms of adaptation. Life transformed limitations into opportunities. This may be the most remarkable feature of evolution. It does not simply endure environmental challenges. It responds to them. Problems become pressures. Pressures create opportunities for experimentation. Successful experiments become innovations. The cycle repeats endlessly. Bioluminescence illustrates the process with unusual clarity. A world lacking light inspired organisms to create their own. A hostile environment encouraged creativity. A limitation became a solution. Seen this way, every glowing organism becomes evidence of nature's flexibility. Not flexibility in the everyday sense, but something deeper. The ability of life to discover possibilities hidden within circumstances that initially appear unfavorable. The oceans offered darkness. Life answered with illumination. The response was neither planned nor inevitable. It emerged gradually through countless generations of experimentation. Yet the outcome remains extraordinary. Even now, the lesson continues unfolding beneath the waves. Modern bioluminescent organisms still transform environmental challenges into opportunities. They still communicate, hunt, defend themselves, and navigate darkness using strategies refined across immense spans of time. Glow persists because the principle behind it persists. Adaptation never truly ends. New challenges appear. New solutions emerge. Process continues. This realization gradually shifts the focus of the story. What began as a documentary about glowing organisms has become something broader. It is no longer solely about marine biology or evolutionary history. It is about resilience, creativity, persistence, the remarkable capacity of life to respond when circumstances seem least favorable. Flashes appearing in the darkness suddenly feel symbolic. Not merely biological events, evidence that life repeatedly finds ways forward. As the pace slows and the journey nears its conclusion, one final thought remains. Perhaps the greatest lesson of living light is that nature's most remarkable inventions often begin as obstacles. And perhaps the deepest mysteries are not those that have already been solved. Perhaps they are the ones still waiting in the darkness, inviting the next generation of explorers to continue the search. The story now moves toward its final reflection, where bioluminescence becomes part of a much larger meditation on existence, mystery, and discovery itself. The story began with a flash, not a dramatic burst visible across an ocean, not an event that announced itself to the world. There were no witnesses. No eyes observed it. No creature understood its significance. It may have been nothing more than a chemical reaction inside a tiny organism drifting ancient water. A faint glow, a brief moment of illumination, something so small that at the time it seemed meaningless. And yet that tiny event may have become one of the longest-running stories in the history of life. To appreciate its significance, it helps to imagine the immense span of time that followed. The oceans changed, the atmosphere changed, entire continents drifted across the planet. Mountain ranges rose and vanished, climate shifted again and again, life itself transformed beyond recognition. Yet somehow through all of it, the glow endured. The earliest organisms capable of producing light disappeared long ago, their bodies returned to the cycles of the earth. Their individual lives ended without leaving visible traces behind, but the idea survived, the adaptation survived. Generation after generation inherited fragments of the same evolutionary innovation. Natural selection refined it, modified it, expanded it into new forms. The glow passed from one age to the next, then came upheaval. Earth's history is filled with catastrophes. Oceans altered their chemistry. Ecosystems collapsed. Entire groups of organisms vanished. Mass extinctions erased vast portions of life, reshaping the evolutionary landscape again and again. Each catastrophe could have ended the story, yet the story continued. Bioluminescence adapted. Some glowing lineages disappeared. Others survived. New forms emerged. Ancient solutions found new applications. The light moved forward through time, carried by organisms navigating worlds that differed dramatically from those inhabited by their distant ancestors. The continuity is astonishing. Imagine a glowing organism drifting through a modern ocean tonight. Its biology reflects millions upon millions of years of evolutionary history. The exact mechanisms may differ from those of the earliest light-producing organisms, but the connection remains. The glow visible today belongs to the same story. It is not separate from the past. It is the past continuing into the present. This realization changes the way bioluminescence is viewed. The flashes appearing beneath modern waves are not isolated events. They are chapters in a narrative stretching across geological ages. Every signal, every pulse, every luminous display carries echoes of ancient oceans that no longer exist. The deep sea becomes a bridge between worlds. A glowing jellyfish drifting through darkness connects the modern planet to ecosystems older than forests. A luminous fish swimming through abyssal waters participates in an evolutionary tradition that began before dinosaurs, before flowering plants, before many familiar forms of life had appeared. The chain remains unbroken. That may be the most remarkable aspect of the entire story. Many things vanish with time. Species disappear. Landscapes change. Civilizations rise and fall. Yet certain ideas survive because they remain useful. Bioluminescence proved useful. Again and again, evolution rediscovered its value. Again and again, natural selection preserved it. The result is a phenomenon that has persisted through some of the most dramatic transformations in Earth's history. The first flash never truly ended. It changed, it evolved, it spread into countless forms, but it never disappeared. Instead, it became woven into the fabric of life itself. Somewhere beneath the oceans tonight, a predator will use light to hunt, a prey organism will use light to escape, a signal will travel through darkness. An ancient adaptation will continue performing the task it has performed for ages beyond counting. The glow remains alive, not as a memory, not as a fossil, as a living process unfolding in the present moment. Perhaps that is the most extraordinary conclusion of all. A tiny flash that seemed insignificant hundreds of millions of years ago continues, illuminating the world today. The journey comes full circle, yet the deeper lesson extends beyond bioluminescence itself and towards something even larger. What this ancient light reveals about discovery, mystery, and humanity's endless search to understand the hidden stories of existence. There is a strange pattern that appears throughout the history of discovery. At the beginning of a journey, a mystery seems enormous. Questions feel impossible, the unknown stretches in every direction. Then research begins, observations accumulate, evidence grows. Slowly, answers emerge. From a distance it appears that the mystery is shrinking. But something unexpected often happens. Closer humanity moves toward understanding, the larger the horizon becomes. The story of bioluminescence reveals this pattern beautifully. When scientists first encountered glowing organisms, the phenomenon seemed almost magical. How could living creatures create light? Purpose did it serve? How did such an unusual ability evolve? Over time, many of those questions received answers. Researchers uncovered chemical mechanisms, evolutionary explanations emerged, ecological roles became clearer. The glow that once seemed impossible became understandable. And yet the mystery never disappeared. It changed. Every answer opened new questions. Every discovery revealed additional layers waiting beneath the surface. Even now, after decades of research, portions of the story remain incomplete. The oceans still guard many of their secrets. New species continue appearing in places previously unexplored. Deep expeditions regularly encounter organisms unlike anything scientists expected to find. Behaviors emerge that challenge existing assumptions. Entire ecosystems reveal levels of complexity that few researchers predicted. Pattern repeats again and again. Humanity looks deeper. Nature becomes more surprising. This is particularly true in the deep ocean. Despite remarkable advances in technology, enormous regions remain largely unexplored. Darkness still covers habitats where no human observer has ever been present. Countless organisms may live entire evolutionary histories without entering scientific records. Some of them may produce light in ways currently unknown. Others may possess biological systems that challenge existing theories entirely. Possibility remains open. That uncertainty is not a flaw in science, it is one of science's greatest strengths. Knowledge does not advance by pretending every question has been answered. It advances by recognizing where understanding ends and curiosity begins. The boundary between those two territories is where exploration happens. Bioluminescence occupies that boundary perfectly. Scientists understand far more than they once did. Yet the phenomenon continues resisting complete explanation. Why did certain lineages evolve specific solutions while others followed different paths? How many forms of bioluminescence remain undiscovered? Hidden adaptations still wait beneath unexplored waters. The questions continue, and perhaps they always will. There is something deeply reassuring about that. Modern culture often treats uncertainty as a problem to be eliminated. People seek final answers, definitive conclusions, complete understanding. Nature rarely operates that way. The natural world is richer than any single explanation. Every discovery reveals connections extending beyond current knowledge. Every solved puzzle uncovers additional puzzles. Bioluminescence demonstrates this beautifully. The story began with a flash in ancient darkness. It expanded into communication, camouflage, predation, evolution, deep-sea ecosystems, and even the possibility of life beyond Earth. Each chapter widened the mystery rather than closing it. The glow became a doorway leading toward larger questions. Questions about adaptation, questions about creativity, questions about life itself. Perhaps that is why mysteries remain so important. They invite participation. They encourage observation. They remind us that exploration is not something humanity completed in the past. It continues every day wherever curiosity encounters the unknown. The deep ocean still waits. New discoveries still wait. New flashes still wait. Somewhere beneath the waves, an organism may already exist that will reshape scientific understanding in the future. No one knows. And that uncertainty gives the story its power. The most important scientific journeys never truly conclude. They continue moving outward, carrying questions into new territory. Bioluminescence is one chapter in that larger adventure. A reminder that knowledge and mystery are not opposites. They grow together. And as the journey approaches its final reflection, the focus shifts beyond unanswered questions towards something quieter. A meditation on what this ancient light ultimately reveals about life, existence, and the enduring beauty of discovery itself. The story returns to darkness. Not because it has reached an ending, but because darkness is where it began. Far below the surface of the ocean, beyond the reach of city lights and distant stars, the ancient world continues. The water moves quietly through immense spaces hidden from human view. Pressure surrounds everything. Temperatures remain cold. The darkness stretches in every direction, and within that darkness light appears. Brief flash, a faint glow, a signal that exists for only a moment before fading once more into the blackness. Then another appears, and another. Process continues exactly as it has for millions of years. Most of humanity never sees it. Cities rise along coastlines, ships cross oceans, satellites circle the planet. Entire civilizations organize their lives around technologies and concerns far removed from the hidden ecosystems below. The world above remains busy, illuminated and loud, yet beneath it all, another world continues operating according to rhythms far older than human history. Organisms communicate, predators hunt, prey escape, signals move through darkness. Ancient evolutionary experiments remain active. Nothing announces their presence, nothing demands attention. The glow simply continues. There is something strangely comforting about that permanence. Throughout this journey, the story followed bioluminescence across immense spans of time. It began with accidental chemistry hidden inside ancient cells. It watched faint flashes become tools of survival. It followed the rise of communication, deception, camouflage, and exploration. It traveled into the deep ocean and beyond Earth itself, asking what living light might reveal about the universe. Every chapter uncovered a different aspect of the same phenomenon. Yet perhaps the most remarkable discovery was not any individual adaptation. Continuity. The process never stopped. Generation after generation inherited the glow and reshaped it. Environmental changes altered its uses. New species emerged. Old species disappeared. Entire ecosystems transformed. The light endured. Even now, somewhere beneath the waves, organisms are solving familiar problems using solutions first developed hundreds of millions of years ago. The details differ. The principle remains. Life encounters a challenge. Life responds. That pattern may be the deepest meaning hidden within the story. Bioluminescence is not merely about organisms that learn to glow. It is about something larger, a demonstration of how life repeatedly discovers possibilities where none seem to exist, a reminder that limitations often become opportunities, a lesson written across geological ages. Darkness appears, evolution creates light, again and again. Response feels almost poetic, yet it emerged without intention. No organism planned it, no force directed it. The glow arose because countless small changes accumulated over unimaginable spans of time, and still it persists. The ocean tonight contains flashes connected to ancient events beyond human memory. Every pulse carries echoes of distant ancestors. Every signal represents a continuation of a story that began long before mammals, forests, or civilizations appeared. The chain remains unbroken. Moment imagine drifting through that darkness. No cities, no roads, no voices, only the quiet movement of water. Then somewhere nearby, a small flash appears. Its purpose may be simple. A warning, a signal, a lure, a message intended for another organism hidden within the blackness. The light shines briefly, then disappears. The darkness returns, but only for a moment. Another flash follows, then another. The cycle continues. Perhaps it will continue long into the future, long after today's oceans have changed, long after familiar species have evolved into unfamiliar forms, long after humanity itself has become part of history. No one can know, yet the possibility remains. The story was never really about a single organism, a single species, or even a single era. It was about life's extraordinary ability to create meaning from challenge, to create connection from isolation, to create visibility from darkness. And so the documentary ends where it began, in the deep ocean, in the darkness, watching a small light appear, watching it fade, knowing another will follow. The story does not end. The light continues.